Welcome, everybody. Mr. Schultz here. All right, so remember the doubling method? We said 2 times at the age was times 35 would be 70 inches. That's how tall the boy, will be when he's a man. All right, so the gray method was 13 over 2 times 65. And so that would be like 70.42 plus 72 divided by 2. So if we add those together, we'd get 142.42. Once again, just use a calculator, okay? Divided by 2. Getting that, what would we get? We'd get about 71.21 inches. Oh, by the way, yeah, that I put it 70 inches right there. Round that down to the nearest inch. That's about 71 inches. So, which one's right? Well, both cases gets around about the same amount. So does it matter? Not really. Which one is going to be the more accurate? We don't know. One method might be better than the other one. All right, but that does lead into the next part. Accuracy. Accuracy is the nearest of a measurement to the true value of the measure. So what does that mean? Okay. How close to it is it? So first up, example 3, decide where to round. So, here's the issue. Like, hey, we have 3 people going on a road trip. If the distance is 172 miles, what is the exact distance? Well, we would say, okay, we'd have 172 miles divided by 3 people. If we actually do that and we divide it out, we'd get 57.3 miles per one person. Now, what would we say? We'd probably want to give an estimate. No one's going to give, cities aren't going to be exactly every mile, but they're not going to be half miles either. So we'd probably just want to say, hey, look, we're going to drive about. So this is about, right? This is estimate right here. 57 miles. Let's erase that. That looks like an 8 kind of. So 57 miles each person. All right, let's go on. Find an appropriate level of accuracy. Okay, so how much should we be accurate? So example 4. There's this huge long problem, and we could have figured out that this space shuttle traveled for 17.168 hours. Now, is that accurate? Yes, that's very accurate. Do we need to be that accurate? No, we don't have to be that accurate. It depends on the situation. So let's type this in. It depends on the situation. Like if we want to land something on Mars, we should probably be really accurate. We don't want to lose tons of money. If we just want to talk to our friends, we'd probably want to say, in this situation, if we're just talking to our friends saying, hey man, it took the shuttle, we'd probably just say, hey, it took 17 hours. That's it. We wouldn't want to be as accurate. It's okay to round in most situations. All right, let's continue. Example 5, determine accuracy. So in this situation, like in the problem in the book, it says, hey, the United States population is 333,287,092. There's 1 birth every 7 seconds, and there's 1 death every 13 seconds. Now, that might be a little off due to this being before the pandemic, but yeah. There's a net gain of 1 person every 11 seconds. I mean, we can't really be that accurate, so we'd probably want to just round to the nearest million. But in this case, we're rounding to the nearest 10th of a million because that's still about 300,000 people. All right, guys. See you later and have a good day. I'll see you guys in class. Bye.